Good morning, everyone. I hope everything is going well. Hope these assignments are going well. They look okay. The work I've been getting looks pretty good. Feel free to stop in and ask some questions during our office hour. This is new material for everyone, so I want to make sure everything is going well. We are moving on here to 32-2. This is all we're going to look at today. So just this section, I'm going to put it all in one video. Don't know how long it's going to get, but we'll just have all the information here in one spot. So find page 494 in your book, and this is where we're going to start. So you should remember from Geo, this was in the getting ready problems, we had these special right triangles, okay? So you had 30, 60, 90, which is right there, and then you had this 45, 45, 90, which is right there, and there was a relationship between the three sides, right? The 30, 60, 90 triangle across from the 30 was always 1, across from the 90 was always 2, and across from root 3 was always, or across from the 60 degrees was always root 3. And those are just the proportions of the three sides. So even if this triangle gets smaller or bigger, the ratios would always be the same, right? So for example, really quickly, if we made this 30, 60, 90 bigger, so say this was 30, and say the hypotenuse was 4 now, well, we know this side over here, the tall side would be 2. Because if you do 2 over 4, you get the same as 1 over 2. So the ratios are always the same, and that's why these triangles are special. And that's why they're called special right triangles. So what we're looking at today is combining these special right triangles with a reminder of what we talked about last week, these sine and cosine functions. We are going to introduce the tangent functions today too, but we're going to start with the sine and cosine, remembering that the input of these guys is an angle. So these functions take an angle, and they spit out a ratio of sides of a triangle. All right. So that's what we talked about last week. Opposite leg over hypotenuse and adjacent leg over hypotenuse, right? Those are the two ratios that spit out. So then what we did was we went to the unit circle. We talked about how these functions look on the unit circle. Now, remember, the unit circles have a radius of 1. That's why 1 unit. That's why we call them the unit circle. And because of that radius of 1, right, so that this segment right here is a radius. You can draw as many radii as you want around the circle. But that has a radius of 1. So what happened here when we talked about sine, which was the opposite leg over the hypotenuse, the opposite leg here was just the y value. So y over 1, which means the sine ratio just turned into the y value of this point right there, right? So that those points along the unit circle, and again, there's millions of them along this unit circle, those xy points are what gave us the sine and cosine values. The cosine value, on the other hand, right, that's the adjacent side, so that was this side, divided by 1, which is the hypotenuse. So same ratios, adjacent over hypotenuse, but in the unit circle, the hypotenuse is 1, which make these equations over here a little bit easier to deal with, okay? So what we're going to do today is kind of combine a lot of the stuff we've been talking about. What happens if we take these special right triangles and we put them on the circle with one of the angles in the triangle in standard position, okay? So imagine we take this triangle and we pop it over here onto the unit circle. Okay, we want one of the angles to be in standard position. So let's say that 30-degree angle is right there in standard position. Okay, so remember, no matter how big or small we make this triangle, the ratios stay the same. All right, but because we want to put this on the unit circle has a radius of 1, we want that 2 there to turn into a 1, right? So what we did, the easiest way to get from 2 to 1 is to divide everything by 2. So if I divide everything here by 2, right, divide by 2, divide by 2, divide by 2, that's going to give me the same ratio. So this side over here becomes 1/2. Write that a little neater. This side here, the vertical side, becomes 1/2, and this bottom side becomes root 3 over 2. So it's the same ratios. We have a 30, 60, 90 triangle here in blue. What we did was we took this red circle triangle, we put it on the unit circle, and we gave it a radius of 1, right? So that's going to help us because if you remember, if you look at this point here, right there, this point on the unit circle, The xy value at that point is 1/2 comma root. I'm sorry, I flipped it. Don't look at that. The xy value, right? You go here. So the xy value here, the x is root 3 over 2, and the y value is 1/2. Because look, over to you start at the origin, you go right root 3 over 2, you go up 1/2, and that's what gets you to the point. All right. So maybe you guys can see where we're going. Look what we said here. The sine and cosine values are related to the xy values of that point. And now using our special right triangles, we found the xy value at that point when this angle right there, that 30-degree angle, is 30. Now, foreshadowing here, that 30-degree angle is the reference angle, right? We worked on reference angles last week too. Let's try to do the same thing for a 45-45-90 triangle. Okay, so same process. Let's say we take this triangle and we pop it onto the unit circle. Okay, in order to get the correct ratios, right, we want this, remember, we want to put it here so that the radius is now 1, right? We want to make that 1. The only way to do that is to take this root 2 and divide it by root 2. Root 2 divided by root 2 is what gives me the 1, which is the radius I want. So divide this side by root 2. I have to divide all these sides by root 2. The nice thing about the 45-45-90 is that these two sides are going to be the same. If you might remember from earlier this year, we don't like radicals in the denominator. So if I rationalize this, multiply by root 2 over root 2, I'm going to get root 2 over 2 and root 2 over 2 for both of these sides, right? So just like I did here, I'm using my special right triangle to get sides of the triangle. These sides, when I take this 45-90 special right triangle and I put it on to the unit circle, the two sides of this right triangle, let me actually mark this. Remember, this is the 45-degree angle right there. It's got to be in standard position. But now the sides of the triangle turn into root 2 over 2 and root 2 over 2. So the xy value here is root 2 over 2, comma, root 2 over 2. So now think about what we did with sines and cosines, right? Sine of theta, the sine of 45, and the cosine of 45, okay? So let's do that last step here. Sorry, I forgot. Let's go back to this screen. There's one more thing I wanted to do here. So now, the whole point of making these pictures is so we could evaluate this last thing. So now that I have this black xy point, root 3 over 2, comma 1/2, think about the sine of 30 degrees, right? The sine of 30, because we're on the unit circle, the sine just becomes the y value, okay? So the sine of 30 degrees, looking at this point up here, is the y value, means the sine of 30 degrees is 1/2. The cosine of 30 degrees, because we want the x value, is root 3 over 2. Now here's what's going to happen. These angles are famous, right? Because of these right triangles, the 30, 60, 90, and the 45, 45, 90 triangles happen so often, you're going to pretty soon just know that the sine of 30 is 1/2 and the cosine of 30 is root 3 over 2. We're going to have a little visual reference thing we're going to make here at the end, okay? So the cosine of 30 is root 3 over 2. So let's go back and finish this. So now, because I put the 45, 45, 90 triangle on there, look at this black xy point. The sine of 45 degrees is root 2 over 2, and the cosine of 45 degrees is root 2 over 2. All right, so let's do this with one more special right triangle. All right, actually, not yet. Sorry, let's do this first. So what radian measure is the same as 30 degrees? Okay, so if we think about that, there's a few ways to do it. You guys learned, sorry, I got to change this real fast. We learned back a few units ago that you can take 30 degrees and you can multiply it by a fraction here. You can get pi radians up top times 180 degrees down low, because I put the degrees down low because I want those to reduce. And this guy becomes, don't have to approximate, becomes 30 over 180, which is pi over 6 radians. So the point of showing you this is we can make these triangles with radian measures as well. 30 degrees and pi over 6 radians will make the exact same little triangle, right? So remember, this is a right angle, so this is pi over 6, all right? So down here, the sine of pi over 6 and the cosine of pi over 6 are the exact same thing as they were for our 30-degree angle, root 3 over 2 and 1/2. So for pi over 6, this point is root 3 over 2 comma 1/2, which means the sine of pi over 6 is the y value, and the cosine of pi over 6 is the x value. Now when I say x and y, remember, the only reason that becomes just the x value and just the y value is because the hypotenuse, the radius, is 1. So really what I'm doing to find the sine of pi over 6, I'm doing 1/2 divided by 1, which is this 1/2. For the cosine of pi over 6, I'm doing root 3 over 2 divided by 1, which is just 1/2. Okay? All right. Now let's do this. What if we wanted to deal with a 60-degree angle, right? So look at this picture here, right? 60 degrees in standard position. Well, if we use the first triangle we looked at, let's flip it here. Let's make this 60. Let's make this 30, okay? And the ratios would be the same. This would be 2, this would be root 3, and this would be 1. So same process. If I divide everything by 2, because I want to make that 2 into a radius of 1, if I divide everything by 2, and by 2, right, I'm going to get the same triangle. But what happens here is that across from the 60 is the root. Across from the 60 is the root 3 over 2. So this side here becomes root 3 over 2. Okay, because that's across from 60. And then across from the 30 is the 1/2. So because the 30 is up here, this side here becomes the 1/2. Okay, so what we have for the 60-degree angle being in standard position, okay, we have a point up here. The x value of that point is 1/2. The y value of that point is root 3 over 2. So when I ask for the cosine and sine of 60, the sine of 60 degrees is the y value, so that's root 3 over 2. The cosine of 60 degrees is the x value, which is 1/2. Okay, so what we've done here, we started off with this in this first quadrant with the 3 most famous angles, right? Back here we started with 30 degrees, we did 45 degrees, and then we did 60 degrees, okay? And we came up with the x and y, the sine and cosine values. Now, we'll talk in a second how this is going to be extended to other angles, a bunch of other angles. But first, let's try this. What about an angle that's not in quadrant 1, right? So if you look at 7 to pi over 4, we practiced doing this and finding other things, coterminal angles and reference angles here. So if I try 7 pi over 4, okay, 7 pi over 4, remember this is pi, so pi is the same as 4 pi over 4. That would make this 2 pi over 4 or pi over 2. That would make this 6 pi over 4, and this would be 8 pi over 4. So again, this is a good skill to be able to set up because you can figure out which quadrant each angle is in. That means 7 pi over 4 is down here in quadrant 4. Okay? So 7 pi over 4 rotates that way. Now, the easiest way to handle this, remember, we're trying to find the sine and cosine of this, we need to find this point. Because this is on the unit circle, so the radius of that is going to be 1. We need to find, there it is, we need to find that point. Now, instead of dealing with 7 pi over 4, I'm going to deal with this triangle right here. Because remember, I'm trying to get that xy point. Boom. So, I don't want to mess with 7 pi over 4. I want to mess around with this, the reference angle. So that's the blank up here. When you're doing an angle that's not in quadrant 1, you're going to have to find a reference angle and then deal with that new triangle to find the value. Now think about this. This is the same pi, so this angle here is pi over 4. So the reference angle is pi over 4. So we can use the same triangle we would have used in quadrant 1, right, for this pi over 4, which is the same as 45 degrees. And we did that. The 45-degree angle here, let's squeeze 45, so pi over 4 or 45 degrees. Look back a few slides. That had an xy value of root 2 over 2 and root 2 over 2, right? So here's the only thing that changes when we go to other quadrants. Remember, the values we're trying to find here are x, y values. You're just on an xy plane here. We added a circle in. So the xy values down there in this quadrant, it would be a positive x value. So the x value here, I'm going to move this out of the way. So the x value here would still be root 2 over 2, right? Because that's this side here. I'm going to the right, root 2 over 2, but now I'm going to go down negative root 2 over 2, right? So when we have angles that are not in quadrant 1, we're going to use our reference circle skills to find a reference angle, and we're going to do the same triangles, make the same triangles we made in quadrant 1. They just might be flipped around depending on which quadrant you're in, right? So these triangles we came up with at the beginning are key, okay? You just need to figure out what XY combinations you want and whether those XY combinations are going to be positive or negative based on which quadrant you're in. So to answer the question, the sine of 7 pi over 4 is the y value of this point we found down here. So that's negative root 2 over 2. And the cosine of 7 pi over 4 is the x value, so positive root 2 over 2. And that's the answer. All right? So find the sine, find the cosine values, or like sine, find the x and y using those basic special right triangle angles we came up with. Remember, these are all right triangles. I might have forgotten to put a right triangle mark on a few of these. Let's go back and check. Maybe a little right triangle there. Right triangle there as well, just to be precise. A little right triangle there as well. So these are all right triangles, okay? So let's do this. Let's practice this a few times. Some of these may be in quadrant 1. I don't think any of them are. So what we're going to do here is I'm going to pause the video, take a minute. You're going to try to make a picture. Remember, if the angle's not in quadrant 1, find the reference angle. Think about which of these 3 triangles it is, right? We have 30 degrees, pi over 6 was root 3 over 2, comma 1/2. The 45, 90 was root 2 over 2, comma root 2 over 2. And then the 60-degree angle was 1/2, comma root 3 over 2, right? So go ahead, pause the video, try A, B, C, and D on page 495. Okay, so let's do this. For angle 300, we should have been able to find angle 300 was in quadrant 4 down here. Oops, go back. Undid that. I want to do that. Sorry. Okay, so 300 is down here in quadrant, like I said, down here in quadrant 4. Right? So right there. So the reference angle, I'll write that here, the reference angle I'm using is 60 degrees. Right? Because if that's 300 degrees, then I have 60 degrees left to get back to that angle, right? So, or back to the x-axis. So if I use 60 degrees, I'm thinking about my 60, 30, 90 right triangle, right? So this little angle down there is 60, right? So that means across from 60, let me go show you again, just to make sure you saw it right. Across from 60 is the root 3 over 2, right? So across from 60, this is root 3 over 2. And then across from the 30 is 1/2. Now be careful. 1/2 is positive. This guy here, the root 3 over 2 is going to be negative. So the point is going to be positive 1/2, negative root 3 over 2. Meaning the sine of 300 degrees is negative root 3 over 2. And the cosine of 300 degrees is positive 1/2. All right, let's do the same for negative 225. So negative 225 degrees. Remember, all that means is it rotates in a clockwise rotation. So negative 225, negative 180 is directly across here, right? So negative 225 is right here, okay? Meaning my reference angle, here's my right triangle. My reference angle then is 45 degrees. So the triangle I care about is the 45, 45, 90. When I put it on the unit circle, the two sides are root 2 over 2 and root 2 over 2. So the point, because it's an xy point, I can have something negative. It's going to be a negative x, so negative root 2 over 2, and a positive y, positive root 2 over 2. So the sine of negative 225 is the y value, root 2 over 2, and the cosine of negative 225 is the x value, negative root 2 over 2. So we got positive root 2 over 2, and then the cosine is negative root 2 over 2. All right. There it is. Let's do C and D here. So some radians. All right, 5 pi over 6. This is 6 pi over 6. This is 3 pi over 6. We started over here at 0. So 5 pi over 6 is here. Right? Reference angle there is pi over 6. Right? So I don't recommend converting these all to degrees each time. You're going to get better and better working with radians. We'll talk in a second about some of the common angles that you'll see over and over again. But I'm thinking back now to the 30-degree angle, because pi over 6 and 30 degrees are the same. So the sides for the 30-degree angle, go back here just to show you one more time. This was the 30, so across from 30 was 1/2, across from the 60 was root 3 over 2. So across from 30 is 1/2 is here. This side here is across from the 60, so that's root 3 over 2. So the xy value at this point up here, again, you can have negative values here, would be negative root 3 over 2, because that's a negative x value, and a positive 1/2. So the sine of 5 pi over 6 is 1/2, and the cosine, that's the y value, of 5 pi over 6, the 1/2 is the y value. The cosine now is going to be the x value, is negative root 3 over 2. All right. Last one for practice. So this last one here, negative 4 pi over 3 is right here in quadrant 2. This is negative 3 pi over 3, starting here at 0. So negative 3 pi over 3, negative 4 pi over 3 is in quadrant 2. If I make the right triangle here, that's the triangle I care about. So my reference angle is pi over 3. Okay? Pi over 3 is the same thing as 60, is in the same spot that 60 degrees would be in. Okay? So 60 across from 60. Let me make this a little bigger. So across from 60, so this is right here, that's the pi over 3, that's the equivalent of 60. So across from that is root 3 over 2. Across from 30 is 1/2. So the xy value at this point up here would be negative 1/2 x value, and then positive root 3 over 2 as the y value. So once I get the triangle, to find the sine of negative 4 pi over 3, that's the y value, root 3 over 2. And the cosine of negative 4 pi over 3 is the x value, negative 1/2. All right. So those are really good examples. It's good. This is the key skill we have to be able to do. Let's do this now to quickly talk about tangent. So if you remember back to Geo, tangent was the opposite leg over the adjacent leg. Okay, opposite over adjacent. So what's nice about tangent is we can keep doing the same stuff we've been doing here. Nothing's changed. So if I put this tangent ratio on the unit circle, if you look at this point here, the opposite leg is going to be this. That's the y value. The adjacent leg is going to be this. That's the x value. So on the unit circle, tangent ratio just turns into the y value of the point here over the x value of this point right there. So again, it's just like the sine and cosine. We're trying to find that xy value using those special right triangles, probably finding reference angles, and once you have it for tangent, you just do the y value divided by x. Okay, let's try one. So check this out, 60 degrees. The 6-degree point, right, using the special right triangles, across from 60 is root 3 over 2. This is a 30, so across from that's a half. So that this point here in quadrant 1 is 1/2 comma root 3 over 2. That's the xy. So the tangent of 60 degrees is the y value over the x value. So it's root 3 over 2 divided by the x value. And you're going to see some fractions here. Don't let that freak you out. Remember how when we divide fractions, we just multiply by the reciprocal here. So I'm going to multiply by 2 over 1, right? And when I multiply that out, the nice thing is those 2's reduce. So the tangent of 60 degrees is just positive root 3. All right? So again, this skill is the same as sine and cosine. You just have to make the triangle and find the x and y values. Okay? We're not going to do all of these. Let's just do a few. Let's go back. We'll do 300 together, and then I'll have you try a pi. We already did 300. I believe I'm right. We did 300 back here, right? So remember, 300 was this picture right here. The point down there was 1/2 negative root 3 over 2. So let's add that in here. It was 1/2 negative root 3 over 2, right? That was using the 60-degree, 30, 60, 90 special right triangle, right? Using a reference angle of 60 degrees, okay? So once you have the triangle set up, the tangent of 300 degrees is the y over x. So it's negative root 3 over 2. Now, when I divide by a half, I'm going to save myself a step here. I know that's really multiplying by the reciprocal, so I'm going to multiply by 2 over 1. The 2's reduced there. So when I get y over x, my tangent of 300 degrees is just negative root 3. All right. That is tangent of 300. So you can see the same, find your special right triangles, and now finding the y over x, okay? Let's do one more here. Don't want to do both of these. Why don't you guys go ahead and try the pi over 4 one. Pause the video and give that a shot. All right, so 11 pi over 4, I should have said. So 11 pi over 4, that's more than one revolution around. Okay, if I want to find my reference angle, this would be 4 pi over 4. This would be 8 pi over 4. So 3 pi over 4 further is going to end me over here, right? So if I was drawing this like we did last unit, this would be the angle, right? More than once time around the circle. I don't need to do that. All I need to do is find the reference angle. So the reference angle here would be 3 pi over 4. Sorry. 3 pi over 4 is where a coterminal angle, but the reference angle would be pi over 4. Distance from that terminal side to the x-axis is pi over 4. That angle right there is pi over 4. So that's the same as the 45, 45, 90. So the sides are root 2 over 2 and root 2 over 2. So the xy value at this point, now be careful, watch out for your signs. It's going to be a negative x, negative root 2 over 2, and a positive y. Okay? So the tangent of this point, tangent of 11 pi over 4, is the y over x. Now guys, don't do more work here. You don't have to cross multiply or anything. You have root 2 over 2 divided by negative root 2 over 2. You guys know that. You know that 5 over 5 is 1. You know that negative 2 over negative 2 is 1, right? So for these 45-degree reference angles, pi over 4 reference angles, it's going to be the same thing over the same thing. It's going to be root 2 over 2 and a root 2 over 2. If one's positive and one's negative, The tangent is just -1. Done. Tangent of 11 pi over 4. All right. So, check this out. This is on page 497. This is the big summary here, right? The terminal side of every angle in standard position has a point that intersects the unit circle. All these little points we've been making the XY values for, right? Now, there's millions of them. We're focusing on some of the famous ones, the 30 degrees, the 45 degrees, and the 60 degrees, right? We also did, last week, we did the 90 degrees and the 180. But using these 30, 60, 90, and 45, 45, 90 triangles, all the angles going to form between these two triangles are given on the unit circle. We're going to do this in radians and degrees. So what I want to do is I want to use these reference angles to come up with the x and y intercepts for these points. Okay. So here's what we got. This is going to be one of your best friends going forward, right? This is the unit circle. We're going to take a second and fill it out here. Let's see if I can do that. Maybe zoom it out. Okay, we're going to take a second and fill it out. But you can see what we have here are all the angles around the unit circle. Okay, from starting here at 0, going all the way around to 360. We've worked on that a few times. We also have it in radians, right? So here's pi over 6, pi over 4, and pi over 3. Remember how we said pi over 6 corresponds to 30 degrees, pi over 4 corresponds to 45, and pi over 3 corresponds to 60. Now, as you go around the unit circle, that pattern keeps going. Okay, so let's talk about the pi over 6's here, right? So if I increase by pi over 6, a pi over 6 plus another pi over 6, that's 2 pi over 6, and that reduces to pi over 3. If I add another pi over 6, that's 3 pi over 6. That reduces to pi over 2. You can keep going with this pattern, right? Another pi over 6 gives me 4 pi over 6. Then 5 pi over 6. And then another pi over 6 is 6 pi over 6. So look what happens here. 5 pi over 6, that doesn't reduce. Sorry, that's a little messy here. 4 pi over 6 does reduce to 2 pi over 3. Which is why that angle there is 2 pi over 3. And 6 pi over 6 reduces to pi, right? That pattern keeps on going along throughout the whole unit circle, okay? So pi over 6's. Now, I told you first day, the degrees are easier. That's exactly what we did with the degrees. 30 degrees plus another 30 is 60, plus another 30 is 90, plus another 30 is 120, right? So the degrees and radians it's just patterns. They keep on going up by the same amount. The 45 angle, for the pi over 4 angle, does the same. The 45 degree angle too. So let's do 45 first. Starts at 45. 45, that's 45 degrees. 45 plus 45 is 90. Plus another 45 is, 45 plus 45 is 90, right? Plus another 45 is 135. Plus another 45 is 180. So that's why the 45s bring you around to 180. Now, if I do that with the radians, it's the same thing. The radian here, this is pi over 4. If I add another pi over 4 here, I get 2 pi over 4. Look what that reduces to, pi over 2. If I do another pi over 4, that's 3 pi over 4. If I do another one, right, that's 4 pi over 4, so that reduces to pi. Right, look, add another one, pi over 4. Add another one, that's 6 pi over 4. That reduces to 3 pi over 2. Add another pi over 4. That's 7 pi over 4. So you can see it's all about patterns here. Okay, so that's how the angles in degrees and radians go around the unit circle. Okay, now the XY values, okay, come from those special right triangles. So let me show you. Let's look in quadrant 1 here. The 30 degree angle here, pi over 6, right, from our special right triangle, we said that this point right here was root 3 over 2, comma, 1/2, right? That was back earlier in the notes. Now, the nice thing about this picture, this unit circle picture, is we don't have to make these triangles every time. We don't have to. That's why that takes a lot of time. That's why this lesson today took a lot of time. So if I know that that XY value is root 3 over 2, comma, 1/2, think about what would happen over here, right? This is the same reference angle, 30 degrees. Think about what would happen down here in red. Same reference angle, right? 30 degrees. Think about what would happen over here in this triangle down here. Same reference angle, 30 degrees. So when I find these points, when I find the xy values here and here and here, it's going to be the same xy's, root 3 over 2 comma 1/2, just some are going to be positive, some are going to be negative. So let's do it. Over here in quadrant 2, the x values are negative, right? Because remember, think about how you plot a point. You start at the origin, you go left, that's negative, you go up, that's positive. So this point right here is going to be negative root 3 over 2 comma 1/2, negative and positive. Let's actually do this in blue. We'll keep these all the same. Okay, so blue. This point here, like I said, would be negative root 3 over 2, positive 1/2, okay? This point down here, if we made that same reference angle, it'd be a negative x, negative root 3 over 2, but it would also be a negative y, negative, negative. Over here, it'd be positive root 3 over 2, positive x, but a negative y. So you see all those blue spots have the same xy value. Some are positive, some are negative, all right? Now, if we did the same thing with the 45-degree angle or the pi over 4 angle, let's do this in red. I wrote around, this would start as root 2 over 2 comma root 2 over 2, right? This spot over here, the only difference, it'd be a negative x, negative root 2 over 2, positive root 2 over 2. This point down here, be a negative x, negative root 2 over 2, and a negative y, comma, negative root 2 over 2. Yeah. Negative root 2 over 2. All right? And then over here, it's already done for us, but look, positive x, negative y. Same xy values, just one's negative, one's positive. Okay? Last but not least, this point here, look where it's starting, 1/2 comma root 3 over 2. Those xy values are going to stay the same. The only difference is this here is going to be a negative x, so negative 1/2, positive root 3 over 2. This point here is done for us. It's negative x, negative y. Look at all these points down here in the third quadrant. Negative, negative. That would make sense. Negative x, negative y is what gets you down there. And then this point here is going to be a positive 1/2 and a negative y, because that's a positive x, negative y. Positive x, negative y gets us down to quadrant 4. So this is by far going to be one of your best friends. We want you to understand that these values come from the special right triangles. But if you can make this picture, then the coordinates of the intersection of the terminal side of the angle and the unit circle are sine, cosine. So basically your x and your y's are your cosines and sines. Makes things nice. Let's just do one of these. Using the unit circle, let's go ahead and find all three values of 210. Let's do the sine of 210 degrees, the cosine of 210 degrees, and the tangent of 210 degrees. Now, you can find the reference angle and make your triangle and all that, but if you look at unit circle, 210 degrees is down here, right? So the xy value is negative root 3 over 2, negative 1/2. If I know that, right, here's my circle. There it is there. If I know that's negative root 3 over 2 comma negative 1/2, I can find the sines and the cosines and the tangents much, much quicker. Okay? The sine is the y value, negative 1/2. The cosine is the x value, negative root 3 over 2. And the tangent, now this one's a little tricky, that's why we're doing this one. But the tangent here would be x over y. I'm sorry, the y over the x. So it would be the negative 1/2 divided by the negative root 3 over 2. So like we said earlier, when that happens, multiply by the reciprocal. So I'm just going to make that picture over there. If I multiply by the reciprocal here, if I bring this up and multiply by negative 2 over root 3, the 2's reduce, but what I get is positive, because a negative times a negative. I get 1 over root 3, which I have to simplify by rationalizing. So multiply by root 3 over root 3, and you get the tangent of 210 degrees to be, I'll show you what I'm doing, multiply by root 3 over root 3, and you get the tangent of 210 degrees to be root 3 over 3. So notice we have some weird things going on. The cosine and the sine here are both negative because they happened in because the angle 210 degrees terminates in quadrant 3, but the tangent of that is actually positive. All right. Now you can try 5 pi over 4 on your own if you want. It's the same process though. Once you have this unit circle, if you have it, it's a great reference. Remember, all of these xy values come from those special right triangles we introduced, and it's a nice reference sheet to make finding the sine and cosine and tangent values a little quicker. Okay, so your assignment today. It's 2 things. There's a lesson 32-2 feedback homework assignment. It's under assignments to submit. This is one where it gives you multiple choice, and when you put the answers in, you'll be able to see whether it's right or wrong at the end. Feel free to do that as many times as you want. And then there's a few problems where I want to see your work. So page 513 through 23. I have the answers posted under homework solutions, but remember, these are only the answers. You must, for full credit, you must show me all work. When finished with that assignment, submit that to Schoology as well. Guys, have a great day, and I'll see you on Thursday. As always, stop by the office hour if you have